Part D wants us to find the values that satisfy the equation cosine of x is equal to 2 over 7. I know that cosine is positive in quadrants 1 and quadrants 4. Okay, so I have cosine of x is equal to 2 over 7. I'm going to apply cosine inverse to both sides. And we get x is equal to cosine inverse of 2 over 7. I'm going to whip out my calculator. And that gives me 1.28. Okay, so that's the angle that we found that's in quadrant 1. So I know that that's 1.28. Now, how do we solve for this angle? Well, I know in order to complete it, I would take that angle and I would add 1.28 to it to get 2 pi, since that's my reference angle. And so the way that we could get the other angle is by doing x equals 2 pi minus 1.28. So I know that was one of my solutions, and then my second solution is going to be 2 pi minus my answer from the previous line, and that's going to be 5.00. Okay, and one thing that I just want to mention is that I am rounding these to 2 decimal places. Depending on what the homework asks, it might ask for an exact solution, and so in that case, you might leave it as something like 2 pi minus cosine inverse of 2 over 7. So that would be the exact solution, although that looks kind of odd, and so I ended up rounding it, but just pay attention to the homework and what it's requesting, whether it be a rounded answer or an exact answer. Okay, so cosine is negative in quadrants 2 and quadrants 3. So I have negative 2 over 7 and negative 2 over 7 here, comma. Now, I could go through all of that where I throw it into the calculator, but if I really thought about this, we just calculated the same thing, because in the previous example, this was positive 2 over 7, and so really this point here is just a reflection of this point, and so this reference angle here is going to be the same reference angle as that one, which, let's remind ourselves from the previous example, that was 1.28 radians here. And so in order to get this angle, what we could do is we could do pi minus 1.28, and then that will give us that angle there. So that's going to be one of our solutions. That's going to be 1.86 radians. And then, let's see, the other one is going to be pi plus our reference angle, which again, our reference angle here is 1.28. So our other solution would be pi plus 1.28. And that's going to be 4.42. So that concludes example 2 for us. Example 3 says use your graphing device to find the solutions correct to 2 decimal places. So these two examples in part A and part B are a little bit different than the previous ones because there is a variable on both sides of the equation and it's not so simple. We can't use techniques like we did in the previous ones to figure out what this is. So for these two particular examples, we're going to need to use a graphing utility, but hopefully we know the general gist of both of these functions. So cosine on the left side, cosine of x looks something, and this is a very rough sketch, looks something like that. And then x over 5 is a linear function with a slope of 1/5 that goes through the origin. So here's 0, 0, and that looks something like that. Now, the solutions to this equation are going to be represented by the points where the two graphs intersect. So assuming I graph this correctly, we're going to have 3 different solutions to this equation. Now, how you would go about doing this on a Texas Instruments calculator is you would turn it on, hit y equals in the corner, and clear whatever graphs you have already. And then for one of the equations, you want to put cosine of x, and in the one below that, you want to do x divided by 5. And I'm going to change my viewing window. Okay, so those are the values that I want to look at within that window, and then I'm going to hit graph in the top right corner. Well, look at that. My graph looks very similar to what the graphing calculator has put on the screen. So now what I want to do is I want to hit second and then calc, which is in the top right corner, the second from the right. And then this screen should show up and I want to go down and I want to go down to option 5 that says intersect, and then I'm going to press enter. And it says first curve question mark, I'm going to hit enter, and then second curve question mark, I'm going to hit enter again. It's basically choosing the two functions we want to look at where they intersect, and we only have 2 functions, so that's good. And then the third question says guess, and so you want to move by using the left and right arrow, you want to try to get a little bit close to the point of intersection. And then once you get kind of close, you can hit enter and it will give you the point of intersection. So we are only concerned with the x value in this case. So the x value for this point here is negative 3.84 since we're solving specifically for x. So one of our solutions is going to be negative 3.84. And then let's see if we did that again. I want to move over to the middle intersection point. That's over here, and I'm going to press enter. And okay, great. So it calculated it for us, and the x coordinate for that middle intersection point is negative 1.98. So I'm going to come back over here and write negative 1.98 right there. And then the last one, okay, I got kind of close. I'm going to hit enter, see what happens. Great, we get 1.31. So those are the x coordinates for where these two graphs intersect at these 3 locations. So our solutions are going to match up accordingly. And these are our 3 solutions to this equation. All right, part B wants us to solve the equation sine of x is equal to x cubed. Once again, I'm going to do a really rough sketch of this. So x cubed looks something like that, and then sine of x looks something like that. That one was not as pretty. Anyways, one thing that's really important to note here is that sine of x and x cubed are both odd functions. And what that means is that they are symmetric about the origin. So here, when we're solving this equation, we're going to have this point of intersection here, and we're going to have this one here and this one here. Now, the 2 points that are not the origin are reflections of each other over the origin. So that's going to help us when we are solving this. Now, in the previous example, I used a Texas Instrument graphing calculator to help us solve for this, but in this one, I'm just going to show you on Desmos. I went ahead and I graphed the two functions in Desmos. I have the red graph, which represents y equals sine of x, and the blue graph, which represents y equals x cubed. And Desmos is so much nicer. You don't have to guess the points of intersection. So they give it to you, and we have 0, 0, 0.929, 0.801, and then the third one is negative 0.929, negative 0.801. So do notice that the two outer points of intersections are reflections of each other over the origin, like I had stated earlier. So if we round this to 2 decimal places, this was 0.93, 0.80. We know that one of the points of intersection is the origin, and then the other one was negative 0.93, negative 0.80. So when we are thinking about our solutions to this equation, they are going to be negative 0.93, x equals 0, and x equals positive 0.93. And that concludes example 3B.